Hello everyone and welcome back to the series of digital logic design, and today we will study the two variables map. We know that for two variable we have four possibility of minterms. Let's suppose we have two variable x and y, so we have four minterms m0, m1, m2 and m3. Now the map for two variable will consist of four squares and each square will represent a single minterm as shown in figure A. Now the map is redrawn to show the relationship between squares and the variables x and y in the figure B. In figure A, we have a kmap with four squares and the minterms are m0 and m1 in the first row and m2 and m3 in the second row. Now if you look at figure B, it has more clear explanation in terms of variables x and y. This also shows that how these minterms are placed in the map. You will find 0 and 1 marked in each row and each column, and this represents values of the variable. For rows we have used variable x, and for columns we have used variable y. The variable x appear prime in the row 0 and unprime in row 1. Similarly, the variable y appears prime in the column 0 and unprime in the column 1 because we are making minterms. Now at the intersection of row and column, we have squares which forms the corresponding minterms. Like for x0 and y0, we have a minterm of x prime y prime, which is m0. Then we have x prime y, which corresponds to minterm m1. Then in second row we have x y prime, which corresponds to x have a value of 1 and y have a value of 0, corresponds to minterm m2. And in last we have x dot y, which represents minterm m3. Now if we mark the squares whose minterms belong to a given function, the two variable map become another useful way to represent any of the Boolean function of two variables. Now, if you consider the function x dot y whose map is shown in the figure A. Now we know that the x dot y function is equal to 1 if x and y both have a value of 1. And on kmap, this can be represented through minterm m3. So for this, a 1 is placed inside minterm m3. And similarly, the function x plus y is represented on map shown in the figure B. And if you look at the truth table of function x plus y, for the combination of 0 1, 1 0 and 1 1, we have an output of value 1. So in this case, three minterms m1, m2 and m3 are marked with 1 in the map. Now if you combine these minterms, we will have function of m1 plus m2 plus m3, and if you simplify them, you will get the result of x plus y. The three squares of the function x plus y could also have been determined from the intersection of variable x in the second row and the variable y in the second column, which encloses the area belonging to x or y. In each example, the minterms at which the function is asserted are marked with 1. Thanks for watching the video and stay connected for more interesting videos.